All right, this is BCA. This is from yesterday, 101 Introduction to Computers. We're talking about networking. And so we started off, we did a little bit of review. Okay, so let's just take a look here. We talked about hardware. Excuse me. We talked about hardware, and we emphasized some things like memory. Most computers, no matter what nowadays, have memory. They have some type of storage. They have a processor. A lot of the devices, like if we were to take a look at these devices, device like a smartphone, the memory and the storage would be together, like a tablet and so forth. They all have to have some type of processor, and then they have some way of moving the stuff around or having ports to connect and so forth. So we have this whole concept of hardware. And of course, what makes the hardware work is software. Software actually solves our problems, or does what we want the computer to do is done by software. And two major areas we talked about: system software, like the operating system managing the hardware, and then apps running with a particular operating system. And then, of course, we got the operating systems for devices like phones, tablets, and so forth. And then we have operating systems in laptops and PCs, and then operating systems running all kinds of things in the world, anywhere from your microwave to your car and so forth. Now, the next thing that we're going to emphasize next is networks, communications. How can we move data? And we're going to talk about how it works. And then we'll finish up in the next unit, Unit 6, we'll talk about security. You only have to secure data because you have to make it available. If you didn't have to make it available, you could lock it all up so only you can see it. But since we have to share it, we have to make it available, like prices for products so we can buy them, or bank account numbers so we can transfer money from one account to another, and you could go on and on with all the things. So what we want to do is we want to make sure that data is confidential. More or less only those can see it that should see it. That people that shouldn't see the data don't. And then we have to make sure the data is accurate. The integrity of the data. The data doesn't get changed when going from one location to another, or the data as it's stored doesn't get changed, and so forth. And those will be the emphasis later on next week. Now, in networks, we started talking about protocols, rules for transmission, and I'm going to give you a number of protocols as examples here in a little bit. But there's some rule for transmission. For example, when a device, like a phone, communicates, gets connected somewhere, there's some protocol that allows that connection. Now, the next major thing to deal with that then is bandwidth. How much can you send through that connection? Bits per second. That's also crucial. What protocol, the rules for transmission, and then how much we can send, and what kind of devices allow us to do this. We have modems, like cable modems and so forth, that allow us to connect into the internet. In networks, they have switches that look at physical addresses of the device and routes information, or I should say switches information to the correct device. We have routers that's going to find the best path of where the information should go, and then we have firewalls to block the movement of information unless it's allowed. Being pretty general, but those are the main ones we're going to talk about in terms of networking. Alright. IP addressing. Devices have a physical address. A lot of times you'll hear people refer to the MAC address. Media, access, control. The media, we talked about media over and over already. We have three major areas of media, right? We have fiber. So we have fiber, we have wired, and we have wireless. Three major air. We can send it through the air, we can send it through a wire, we can send light through some fiber optic cable. How do we access that? Okay, we can keep track with a media access control number, physical address in the device. Then we have a logical address, which would be IP, Internet Protocol. And it's some number given the device. For example, you could have your laptop on the college campus. Your laptop still has its MAC address, but when it connects to the network here on campus, it gets a logical address from the campus. Now, if you're at McDonald's, you'll get a different logical address at McDonald's. And we'll learn more about those later. Okay? We connect our local devices into a LAN, and then from the LAN, we're able to connect through a WAN. And that has a lot to do with the IP address. Topologies. A logical topology, I'll show you one here in a minute, shows logically how the network works. A physical topology would show you where all the cables and so forth. And we tend to work with network designs that are hierarchical and usually some type of star. We have a device and then we extend out from that device. It connects to another device which could extend out, and then we have a hierarchy and this star type structure. Alright, so here we have a picture of network design. This is a logical design. This is a logical design. Okay, so here in the classroom, we can take a look at, we have all those blue cables connecting